All right, everybody. It's about 9 a.m., so I think we're going to try to get started here. I know we have a few people still logging on at this point, but we've just got a small intro and kind of welcome y'all. We appreciate all of you guys, making the time. I know the rain definitely helped last night in a lot of the area, kind of slowing things down. So we're happy to have you join us, and I am going to pass this over to Gary for an introduction.
Well, good morning, everybody. Thank you for joining us this morning. As Steph just mentioned, a lot of the areas got, I don't know what the rainfall was. I think Dwayne told me earlier that it was anywhere from 1/2 to 4 inches or something across the district. So things are looking good. The weather's supposed to be nice again, but I want to welcome everybody here this morning. I know this is a busy time of the year and probably just getting nothing but busier. So we're going to go on. I want to introduce myself. Steph, on the next slide, we can go. I'll introduce myself. My name is Gary Fellows. I'm the district manager from Minnesota, southern Minnesota, and eastern South Dakota. I live over just south of Minneapolis, about 45 miles in a town called Faribault. So located there and originally from southwest Minnesota, a little town called Worthington, farm kid from down there. But what we want to do, in addition to welcoming, what I want to do in addition to welcoming you this morning and thanking you for attending, is to just talk a little bit about Liberty. What we've seen this year is the Liberty traded acres are increasing dramatically. I think we've all seen that, depending what we do, whether they're E3s, whether they're Extend Flex, GTLLs. The amount of acres of soybeans out there that can take Liberty is dramatically increased. And with that, the Liberty demand has kept pace with that increase, right? We're seeing a lot more demand for Liberty. But really what that means is we've got more users and more acres in 2021 than we've ever had before. And what we want to do is make sure that we get the best information out, how to use that Liberty well. And so we can go to the next slide, Steph. The key thing I want to talk about too is we're going to cover in more detail than just this slide as we go through some of the takeaways we learned in 2020. By and large, most of the areas saw very good performance with Liberty, but there were some fields that didn't look as good as we would like them to be. So what happened in there, and we'll cover that, but really that early soybean planting last year, we had some, and I've got in here non-performing pre-herbicides. I say non-performing, could say low-performing pre-herbicides, kind of meant that first Liberty application got sprayed the first week of June, and probably a little earlier than we have had in the past. And that brought on some special conditions. The other thing is with that earlier soybean planting, we had fewer weeds controlled by tillage. We again had some of those pre-failures that just didn't, the pressure was pretty high for the Liberty. And by the time we saw it and the range of weed sizes that we saw coming through those pre-failures. And in some cases, if you guys think back to 2020 or 2019, we had all those prevent plant acres that were coming into cropping in 2020. And whether there was an entire field or just the drowned out spots from 19, we saw tremendous weed pressure in those spots. And I think you guys probably all saw that when you walked your fields where we had those tremendous weed pressures. This is not the time where you want to skimp on your quality of your pre-herbicide. You want something that's really going to go after it because the populations were high. The other thing we saw, and we're going to talk about in more detail, Dwayne's going to cover, is that in early June, we had some very windy, but warm and dry conditions. And it really changed day to day, even some cases morning to afternoon, where we had some dramatic drop in environmental conditions and a drop in relative humidity. And that really changed the activity of the plants. And so we're going to talk about that today, because really, if you look at my next, what we want to cover is in today's objectives, we want to review and confirm the best practices for Liberty applications. So these new users, new growers, even those that have been using it for a while, get the best response. We want to learn from 2020 how to increase our weed control consistency and how to do the right things in the right weather. And finally, how to show the Liberty flexibility, how it fits into so many different systems. And this is a really customizable herbicide for your practices. And so those are the objectives I'm going to cover today. The only point I didn't have on my slide here, if at any point you have questions, there's a chat box on the bottom that you can go over and type in a question. We'll either address it if it's specific to that slide, we'll address it there, and I'll interrupt the speaker. We'll make sure we cover it. We might type the answer in, or we'll make sure we cover that question when we come to the end. So keep in mind, anybody wants to type in a question in the chat box, we'll address those when we can. So with that, I'd like to pass it off to the next speaker, and thank you again for showing up this morning.
Thanks, Gary. My name is Wyatt Kaufman. I'm the technical service rep for South Dakota. So I cover the entire state of South Dakota, and I'm going to go over our STOP guidelines today, the basic acronym that we use to make a good Liberty application. Before I do that, I want to just talk about a little bit the basics of how Liberty works. So Liberty is a group 10 herbicide with the active ingredient glufosinate. And so being a contact herbicide, it requires even distribution across the leaf for it to work and be able to fully control the plant. It also needs ammonium sulfate to be fully effective. And so I will cover that more in depth as we move on to some of our slides here. So as I mentioned, the STOP acronym is the general guideline that we use to make a proper Liberty application. So the S stands for start clean and stay clean. So we want to either use tillage to start completely clean and then use a good pre-residual to keep weeds from coming up with the crop, or use a good burn down and keep weeds from being there when we plant the crop, and then keep them from coming up as the crop goes along until we can make a post application. We want to target less than 3-inch weeds, and this also is helped by the S part of this, to start clean and stay clean. And then we also want to optimize coverage using the right nozzles, the right carrier volume, and making sure that we get good coverage of these weeds, because we are using a contact herbicide. And then we want to pair with residuals to make sure that we don't have to make another application and we can just leave the field as it be through the rest of the year. So some of these I just covered, and I'll cover more in depth, but some of these I'll cover more as well. So again, I mentioned carrier volume in kind of the optimizing coverage portion. So we recommend 20 GPA. Nozzles and pressure, we're targeting medium coarse droplets, like a flat fan nozzle. And then I'll talk more about time of day and why we use AMS in the formulation as well. So as I mentioned, start clean and stay clean, the S portion of this acronym, we want to use an effective pre. And this is a picture I took from a university trial near Beersford, South Dakota last summer. This is about 4 weeks after application. You can see the untreated check here on the left, where there was no pre, how many weeds we have to control there that are almost the same size as the soybeans, compared to 6 ounces of Zidua Pro on the right. And essentially the message that I want to get across here is that we just want you using a multiple mode of action effective pre, so that we can reduce that weed population from the start and have less weeds to control with our post application, and also have a wider window of application with our post application and target those smaller weeds. So I mentioned smaller weeds, and here's a good visual diagram of what we're trying to do when we target less than 3-inch tall weeds. So you can see on the very far left of the screen, that's a plant that just emerged. It has 1 growing point to control. That's the same number of growing points that you control with a pre-herbicide as well. When you kill it before it comes out of the ground, it's 1 growing point. But that quickly, as it grows, a 2-inch plant now has 2 growing points, and those double with every 2 inches in height. The growing points start to double. So you can see here why we're targeting less than 3-inch weeds, especially with a contact herbicide, because we have to control all of these growing points to be able to kill the plant. Here's a demonstration of what we're trying to achieve with water volume here. So here is, on the left side, is Liberty at 10 GPA with XR nozzles. So you can see we didn't have enough carrier volume and how much difference that makes in getting the good coverage here. And there were no pre's in these plots, so they're going to be very heavy weed pressure. On the right side, you can see Liberty with 20 GPA, but with AI nozzles. So that would be like leaving your nozzles in that you made a dicamba application with. And then in the center here, you can see Liberty at 20 GPA with XR nozzles. So you get that combination of the right droplet size and the correct GPA, and you get that maximum coverage here. And the only weeds that are still left are the ones that were covered up by larger weeds when the application was made. And then nozzle selection is obviously another very important part of making an effective application. So you can see here two options, and this is in a cotton plot with no pre, two options for making or choosing the right nozzle. So we have a flat fan that produces a medium droplet on the left side, and in the center, we have a turbo drop that produces a medium droplet as well. You can see compared to the air induction, which produces a coarse droplet, again, kind of that dicamba nozzle on the right side, the difference in those. And I mentioned, why do we add AMS? So this is a big part of how Liberty works. And one key step in the process of how Liberty actually kills the plant is it overwhelms the cells with ammonia. So by adding AMS, we can soften the water and actually condition the water, take out some of our hard water elements that are very prevalent in our area. And then it also helps aid in leaf penetration. So we get kind of three benefits out of adding AMS, and we like to see at least 3 pounds of AMS go in the tank to maximize those benefits and really give Liberty that boost it needs and give it the extra ammonium to begin working and begin killing the plant as it absorbs the herbicide product. So now we've talked about kind of application and what we want in the tank. I want to talk about what we should be looking for as far as conditions to make Liberty work the best. So Liberty kills plants by targeting a light-driven reaction within the plant. And you can see that in these pictures specifically, where they sprayed at 6 a.m. or 9 p.m., they just didn't have that light intensity, and the plant wasn't functioning fully like it would throughout the day, carrying out photosynthesis. But when they sprayed right in the middle of the day at 2 p.m., they got that full photosynthetic activity that the Liberty could get in and disrupt that process and ultimately be much more effective than spraying, at 6 a.m. or 9 p.m. So we recommend spraying 2 hours or more after sunrise and no more than 2 hours before sunset in most situations in order to capture as much light as possible and make Liberty as effective as possible. And then the last part of that acronym was P, using post-residuals. So we're trying to, when we use a post-residual, prevent a messy situation like this. And this is a picture that I took last fall, driving home one day. This field that I drove by almost every day didn't have these weeds poking through for most of the season. And then as we got later in the year, they started to creep through. And I don't know the specifics of the field, but I suspect there wasn't a post-residual used. So using that post-residual helps to prevent new weed emergence throughout the seed. Water hemp continues to emerge, albeit at a lower rate throughout the season, but it does continue to emerge. So using a post-residual is key in order to prevent messes like this at the end of the year. That way, we hold back that water hemp until the beans can actually canopy and make sure that we reduce the weed seed bank and have less weeds to control in the future. And then finally, I just wanted to highlight how Liberty works and why it is superior to any generic form of glufosinate on the market. It is 60% performance delivered by the AI, and then 40% of the performance is delivered by the patented adjuvant package that's within it. So that's why we typically don't recommend a lot of other things to go in the tank with it, because that adjuvant package is built in with it, and we have the superior adjuvant package with the formulation, and that's what makes Liberty the best glufosinate on the market.
Thank you, Wyatt. With that, we are going to be switching over to Mr. Dwayne Rathman, who's going to be speaking about, improving consistency in challenging environments.
Yep, good morning, everyone, and thanks to everyone for going on. A great morning and a lot of people on board. I see there was a question on pressure. So Wyatt, I think you covered that a little bit, but certainly I guess with pressure, we want to make sure we end up with the medium to coarse droplets. And so pressure kind of depends on the nozzle you have, the orifice size, but I would guess that with most nozzles, you want to be at least 40 PSI, 50 PSI, 60, somewhere in that range. So what I want to do is cover what Gary talked about at the beginning, and that is, you know, it's great when Liberty works well, and it does most of the time. But last year, especially in western Minnesota, we had some very challenging conditions, and I can tell you, we had some fields that didn't give the performance that we wanted to, and so we really dug into that in a number of ways, looking at the field comparisons, looking at the literature. And so let's take a look at what we can do when things aren't necessarily in our favor as far as the environment goes on the next slide. So I kind of break it in two areas. Number one, just logically thinking, let's do all we can to get more inside the plant, inside the weed. You'll see there's two steps of this, but step one absolutely is getting more in the plant. So how can we do that? How can we reason through that? Well, we know one thing. There's three things that really control Liberty performance. One is temperature, so you get less absorption with lower temperatures. Another is humidity. You also get less absorption and control with lower humidity. So we do need to set some guidelines the best we can. 70 degrees is a good baseline temperature for Liberty activation. The hotter, the better. But if it's much colder than 70, that is going to limit the amount of product you get in the plant. And then with the humidity, we certainly see a higher humidity getting better absorption and translocation. And this was very evident last year, because this was probably one of our most limiting factors last year, was relative humidity during the first couple of weeks of application. So when you think about it, to optimize Liberty performance, you need to get as much in the plant as possible. And really that all starts with everything that Wyatt just covered. I mean, he did a good job covering the stop guidelines. And you know, I don't need to repeat those, but think of it as two steps. One, getting more into the plant, and then we'll cover the second step as well. But on the next slide, let's take a look at the environment under challenging conditions last year. So this is from western Minnesota. I tracked on a lot of fields I looked at. I tracked the relative humidity and the time of day. So this is tracking 9 a.m. to 6 p.m. Normally good application times for Liberty. You know, it's 2 hours after sunrise. It's less than 2 hours before sunset. But we noticed certain days really gave us some fits. And one was June 4th. June 4th, we saw the relative humidity in the canopy or in the field, and considering in the canopy for absorption, we saw that to be very good, and you know, in the 60s at say 9 and 10 a.m. But on June 4th, extremely dry day, by noon, we were down to the 30s relative humidity, and it remained in the 30s through the afternoon. And I had two examples where a grower applied Liberty at say 9 or 10 a.m. and got pretty good results. And then for some reason, I forget, they had to go to work or they had some other things to do. They came back and sprayed the rest of the field at say 3 or 4 p.m. And it was almost night and day. We had much less performance, poor performance at that middle afternoon. And the thing that I noticed the most, the temperature wasn't that much different. The sunlight wasn't that much different. But boy, the relative humidity was dramatically different. So let's compare June 4th to June 8th. And on June 8th, which is the green bar now, June 8th, I looked at fields sprayed on June 8th, and we didn't see this problem at all. And so I made that comparison. What's the difference between June 4th and June 8th? And again, it seemed to be relative humidity. Whereas on June 8th, the relative humidity, you know, started out similarly in the morning at 60, 70%, and it'll always dive during the day on a normal day, but it never dropped below 40 relative humidity. And that seemed to be enough of a gap. So the gap there on the next step slide, we saw good control all day, but look at that gap between good control and poor control. You know, 35% relative humidity to 60% relative humidity at noon. And those are some days we can't control the weather, but what can we do about it? So let's talk about that. So on the next slide, I'll just show you this example of one of those fields sprayed on June 4th, where you kind of just shake your head and you realize what's going on. So this was a field sprayed on June 4th. There's common lamb's quarters, obviously a big one, so much bigger than we'd like. But the relative humidity was in the low 30s at the time of application. And let's face it, lamb's quarters is a hard to wet leaf on a good day. And again, you can see the outer leaves that were exposed at the time of application. This is about 2 weeks after. The middle leaves obviously grew since then, so they're untouched, but very little activity. So number one, there was good sunlight, but we just didn't get enough product into the plant. So thinking of that, let's go on to the next step. What I did, I took a look amazingly, there's still a lot of research being done on glufosinate, on Liberty, and how it works. So just 2 years ago, there was a very interesting paper published by Dr. Phil Westra. He's a weed researcher I work with out in Colorado. And the title was Reactive Oxygen Species Trigger Fast Action of Glufosinate. So what does that mean? Well, his main conclusion was that glufosinate is really, what it's really doing, it's toxic to weeds or plants due to a massive light-dependent generation of what's called reactive oxygen species, or ROS. So what he's saying is plants need sunlight in order to be killed by Liberty. So these reactive oxygen species are responsible for the very quick control you see with Liberty on weeds. And they've also did work with Liberty in very dark periods, or even in the complete dark. And pretty much there is no weed control without sunlight. So it just demonstrates the importance of sunlight, of activating those oxygen species and destroying those weed cells. So obviously what we know is the greater the length and intensity of sunlight you have, the better weed control you're going to have. So that's really step two. Step two, as much as you can, and we can't control everything we do and every time we spray, but spray under the highest sunlight possible. So that goes back to Wyatt's comments on not spraying too early in the morning or too late in the day. If you have a really cloudy day, you may be better off, if you have the opportunity, to wait for a clearer day if that's in the forecast for the next day. But realize that in order for sunlight to do its job, you have to get as much in the plant first, and then you let the sunlight do its job. So sunlight is, again, key to that reaction, and you don't get weeds controlled without sunlight. So if possible, pick the best days and time of day to maximize that sunlight. So all in all, you think about that step two. What do we do? What do we do when we get those conditions that we saw last year in early June, where we had very hot and dry conditions? We had all the things kind of going wrong. The pre's weren't working well because it was so dry. What do you do when both when temperature, relative humidity, and sunlight are really not on your side? Well, number one, get as much in the plant as possible, right? So that's all about the stop guidelines. Using a pre, remember that Liberty rate, weed size, droplet size. And then number two, remember that light is needed. So the additional learnings we got from 2020 under challenging conditions were, number one, what's one way to get more into the weed? Well, it has to do with the rate. And we did see a benefit of people moving to that 43 ounce, the top rate of Liberty. 32 seems to be the standard, and that's fine under great conditions. But if challenging conditions, 43 will do better. Also, we definitely saw an enhanced level of control with tank mixes of glyphosate or tank mixes of Enlist. And I'd have to say even tank mixes of the clethodim or select products. All of those tank mixes, either due to surfactant load in those products or the active ingredient themselves, gave us more consistent performance than a Liberty alone application. And then when things aren't on your side, remember getting more into the plant. How do you do that? Well, one way also is to use additional adjuvants for increased absorption. So additional surfactant or crop oil is definitely beneficial when things aren't on your side. And then going back to the time of day, knowing that sunlight is very, very important to that final kill weeds yet. Time of day. So what we saw is that mid-morning may be optimum, maybe for two reasons. Number one, we saw that relative humidity being optimum mid-morning. And then you also know you're taking advantage of sunlight through the rest of the day. So those are some of the things we learned in 2020. I hope that helps. That doesn't solve everything. You can't control the environment, but you definitely can adjust your application to try to get more into the plant and try to take advantage of all the sunlight you can get. So with that, maybe I'll turn it over to Steph and she can talk about our recommendations for 21.
All righty. Before we jump into mine, Gary or Wyatt, are there any questions that were in the queue that need to be answered?
Sure, Steph. Yeah, there was actually a couple of questions that came in and we've typed some answers in, but maybe people didn't see the question. One of them had to do with what Dwayne just talked about. Do we need additional non-ionic or COC with Liberty when we're spraying under tough conditions? And the answer is yes. Anything we can do to increase uptake into the plant, especially under tough conditions, increases our control. The more Liberty gets in the plant, the better it is. Yes, Liberty has a ton of adjuvants in the system, and that's all great. It makes it work the best of any glufosinate out there. But an additional non-ionic and COC is certainly going to help when things get tough. We also had a question regarding leaf cupping, and where somebody had seen leaf cupping and there's no dicamba within miles around that. Liberty does not really cause leaf cupping, but what you see that leaf cupping, typically when we see that with Liberty, it's because of the AMS. And we know that if we just applied AMS under certain conditions, we will get some leaf cupping. It's not a harmful effect. It's just kind of the plants kind of get a little bit in too much, maybe overgrow just a little bit, show that cupping. It's pretty easy to tell if it's cupping with that because the new leaves that come out are completely fine, and you'll just see that cupping. Give it a couple days, and you won't even notice the cupping because the new leaves have grown right on top of it. So it's that's not a Liberty effect, the leaf cupping. It's the AMS that's in the system. The third question we had so far had to do with nozzles, and Wyatt put an answer in there talking about the type of nozzles. And again, we're looking for medium to fine droplets. Again, better coverage. This is a contact herbicide. The best coverage we get means this a little bit smaller droplets, not those giant fat ones that you get with an air inducted nozzle or some of the other ones, but some medium ones to get maximum coverage. So that covers the questions for now, but keep them coming in. We'll address, if anything new comes in, we'll address it as we get it. Thanks, Steph.
Yep, no problem. And we will also have a little bit of time at the end as well for questions if we need to have any other ones that kind of pop up as we go.